This exercise focuses on tan. And one thing that we know about tan theta is that it can be defined as sine theta divided by cos theta. Now remember, cos theta, we just looked at this in our last lesson, cos theta was on our x-axis and sine theta was on our y-axis. So if we know what our values are for cos theta and sine theta, then we can put that together and find tan. So let's have a look at that in the next example. Now, following on from our examples in our last lesson, we already worked out what sine of minus 5 pi on 2 was and cos of minus 5 pi on 2. So that's what we need to complete this. Sine of minus 5 pi on 2 over cos of minus 5 pi on 2. Tan is sine divided by cos. And we already know that that is minus 1 and that is 0. And that minus 1 divided by 0 is equal to 0. So not so difficult, but you do have to break it down into its two components. So this one here, we've got sine of minus pi on 2, cos of minus pi on 2. Now we can use our unit circle here, and when we use our unit circle, what do you get? Right, we can see that sine of minus pi on 2 again is minus 1. It's in exactly the same spot, isn't it? And cos of minus pi on 2 is equal to 0. It's our x value. So minus 1 divided by 0 is 0. The next ones are very difficult to do just using your unit circle. And yes, we could have done the top ones in our calculator, but these ones we will definitely do in our calculator. What is important here to remember is that you are finding tan of a radian. So your calculator must be set to radian before you put these into your calculator. So when you put tan of 1.9 into your calculator, you get negative 2.93. When you put tan of negative 2.8 into your calculator, you get 0.356. Now remember, tan of 1.9, that was a positive angle, so you were moving in an anti-clockwise direction. And tan of negative 2.8, you were moving in a clockwise direction because it was a negative radian.